Okay. Now I hope you can see my screen. Okay. So we are in today's session, right? First of all, welcome to the PodTest Automation Architecture Bootcamp. This is episode 5, and we have already held 4 different episodes, which you can check on our website, which is or not on website, on the our YouTube channel, which is this. So if you are interested to look at the back episodes, please refer this URL for my channel, and it should load up. So over here, right, you can go and check the playlist, and within the playlist, you can check the previous episodes which are here, Architecture Bootcamp. So till now, we have covered 4 episodes, 4 different episodes. So the episodes are about client server architecture, where I've explained how client server architecture works. Then Selenium Grid. Then we have explained Selenium architecture. Then we have shown like how to use performance parallel execution, and how does we need to first understand how to manage the sessions, WebDriver sessions, and then use Java concepts to handle the parallel execution. So everything is discussed there. Now today's part, right? For today's discussion, we have a topic, exciting topic, which I think anyone who wants to work with Java should be knowing, which is about working up with. I mean, get some understanding on how the stack and heap are used by Java, right, in memory to store your variables, methods, and the objects. Okay, your variables, methods, and objects. How does everything get stored in the memory, right? That is the question. And for doing that, right, what Java does is Java uses these 2 data structures. One is stack and heap, right? We don't have to understand these data structures, but we'll try to understand, like, if you create a variable, method, object, right, where they get placed and how they are accessible to others. Okay, this will help you when you are working with objects, right? When you try to create some objects using Java, this will really help you to understand, like, how the operation is happening. Okay, and this is again a good information, a good piece of information to become better in Java. Okay, so let's start. So first of all, right, we what I've done for this is, like, I've created a program which I will show. But before that, let me just get some basics right. Okay, so that we are aware about the terminology which will be used. So the first thing, right, let's say if you have to create an object of a class, how do you do it? You simply write, let's say there is a class called car. Okay, and whatever there is, right, it could be anything here, but this is a car class, right? If you have to create an object of it, how do you do it? You do something like this: new car and this, right? What? So by writing this new keyword, right, itself on on that class name, it creates an object, right? So this entire thing results into creation of an object. Creation of an object. Okay, now what we do on the left hand side, we do what? We specify the data type, right? Data type of this object. Now this object is being created of what type? Of car type, right? So we mentioned that here. And we need to provide a variable here, the name which we would use to refer this object. So let's say we termed it as C1. The terminology used is that this is termed as reference variable. Okay, in terms of technical terms, it is said as reference variable, and this is the data type of this reference variable. Okay, data type of this reference variable. Okay, so if we are clear with this terminology, right, that where the object creation is happening, it is happening on the right hand side. How Where the assignment is happening, it is happening to the left hand side, right? And in the left hand side, you have to understand what is car, what is C1 over here, right? This is like data type of this variable, right? This is like a data type of this variable, and the technical term for this variable is reference variable. Okay, good. If we understand this, I think we're good. Let's move ahead. Let's go back to our original discussion of the stack and heap. Okay, to understand this thing, right? First of all, let's understand. Let's just understand the basics about what are these stack and heap, right? So stack and heap is nothing. These are like data structures. Okay, these are data structures which you would read about or know about, but I will just give you a basic idea. Okay, so if you would talk about stack, right? Stack is nothing like if you would arrange some plates, right, one on another, right? So it forms a stack. It forms a stack, right? So this is like a linear data structure where you could have, like, these are like, if I compare to that analogy of plates, so these are different plates, right, or different things placed one after another, right? And this is a complete thing. It's a stack. Okay. Now there could be an order, right, in which you are placing things. One could be first in, first out. Okay, first in, first out, right? This is called as FIFO. Another could be LIFO, which stands for last in, first out. Okay. Again, we don't have to worry about these things. I'm just trying to explain you, like, these are the different operations in which stack can work. What Java uses, we don't care. We just have to understand that this data structure is used by Java to, in the memory, right? In the memory to store some of the variables inside this, right? And what all, we'll talk about it. What is heap? Heap is a data structure which is based on trees. Okay, so it's a tree data structure. It's a tree data structure, right? Which is I think, which is a binary, which follows the binary tree pattern. Okay, right? A node like this, you will have a node below this, right? A tree structure, right? Right? A tree structure like this, right? But again, we are not concerned about like how this is formed and all, but it is good to just understand like what is a heap, right? It's a tree data structure which follows binary tree pattern. Okay, what is stack? Stack is like this linear data structure where things are placed one after another, right? You move things out, you push things in, right? So that is what these data structures are. Now coming back to our original discussion, right? Will we have understanding about how to create an object? We saw that, what are the terminology involved. We understood what is stack and heap, and we have some idea like what are these data structures and how they look like. Okay. Okay, so this is enough, right? Now coming to the actual part, which is our code. Let's say I have a code written in Java, right? And what I'll do is I'll try to explain you, if this is our stack. Let's say this is our stack. Okay, so again, Java uses these two data structures in the memory to place the variables, methods, or the objects it creates during the execution. Okay, so this is a stack, and let's say it's a heap memory, right? Now, okay, let me first show you a program. So see here, I created one program which is this. Okay, over here you can see I have two classes, student and app. Okay, student is just an empty class, nothing is here. Okay, and there is a class named app. Okay, and inside this we have all of this. Okay, now people who are aware, right, about Java, they would be understanding like this is an instance variable and it's a local variable. Okay, this is a local variable, this is a local variable, right? Like this is a local variable, right? And these are methods. Main is a method, work is a method, set name is a method, and this is where object creation is happening, and this is your reference variable, right? I hope we understand this part, right? So what I can do is, just a second, let me do one the part. If let's say, let me write it here. Let me do, so that we can have it covered there. Okay, just a second, let me do it this way. Tool, and if I do something like this, let's say uh, class student, let's say. Okay, let's say class student, so that I can see everything here. And let me remove this, delete. Okay, so we are good. And now that snipping tool, let me grab that. Let me just oh, sorry. Okay, I got this, and let me just grab this. Okay, okay, so this is there, and now let me just save this, and I will use it as a reference on that whiteboard. Okay, just give me a sec. Let me just copy paste this, and uh, where is this? Let just full stack estate. Let's place here. So that is my image. Uh, Java heap. Okay. Let's say save. Let me close this. Let me go back to here, and it would be much more easier for me now. Let me upload image, and if I come here, Java heap. Okay, so I have this code here. Okay, and let me just make it small so that it can sit here. Okay, fine. Right, now let's resume. Right, so we have to first understand about different terminologies which I just mentioned that we should be knowing about. Okay, just a second. Okay, right, so what we should be knowing about is different terminologies. If you would see, this is one class, right? So what are classes? This is a class, right? And this is a class. Okay, this is a class. Okay, great. What are these two things? These are variables being declared, but these are what? These are instance variables. Okay, anything, any variable which you create inside a class, right, which is outside a method, these are outside the method, right? These are not sitting inside any of these methods, so these are called as instance variables. Okay, now, so these are instance variable. S and name are instance variables. What is main, work, and set name? These are methods. These are methods. So name is a method, work is a method, and set name is a method, right? These are all methods. What is args? What is this? P, and what is this? P here, and what is this here, right? Now let's just do it one by one. Local variables. What are local variables? Any variable which you define inside a method, right? Whether it's through the parameters like this, or inside the method, right? Like this. P is a, so P is a variable created which is of type what? App. Okay. So what are the local variables here? Args is a local variable. Great. P is a local variable. Okay, fine. What is new app? New app is an object. Okay, it's an object which got created. So new app is an object. Okay, so this got completed. Let's move ahead. Work is a method we already did. App, again, app is also a local variable here. This app double p, and again new student is again an object, right? We created an object here. And s over here, right? S we have already covered. S was an instance variable, right? S was an instance variable. What is app dot set name? Set name is a method again, right? But we see this text here, right? This is a string. And what is string in Java? It is an object. So again, an object, right? Now coming to this part, set name. Set name is a method which we have already defined. It's a method. What is the student name? This student name is also a local variable, right? And what is name? Name is what? Name is an instance variable which we have already identified. Now, I hope now we understood, we classified everything inside our program into these categories. What is a class? What is instance variables? What is method? What is local variables? What is an object? Okay. Now, what we have to do is we have to first understand like what Java does, right? What Java will do is Java will classify like this, like how we did, right? How we did it, and Java will do what? Java will decide like what, which things to place where. Okay. So the rule is all the objects, let me write it here, all the objects which you create, right, would reside on the heap. Okay, all the instance variables which you create would reside on the heap. Okay, so these are the two things which will reside here. What about stack? What will stay in stack? Stack will hold local variables. Okay, stack will hold local variables. It will contain the method names, right, what we are providing. And I think we are good with this, right? Class is just a thing, right, where you're defining all of this, right? So let's park it away. So we'll try to understand how these four things are placed where, right, we got the answer, right? So all the local variables, right, which we have created will reside in this stack. All the method names, right, which we are creating will reside in the stack. And what would be residing under heap? What will be residing? The objects and the instance variable. Let's start doing it one by one, right? So let's see like, as the program started, right, first of all we reached to this line student s. We understood it's an instance variable where it would be stored. Okay, it again instance variable, right, is would come into picture when you create an object. Okay, but as of now just understand it's an instance variable. Okay, so let's leave it now as of now. Let's move ahead. We move to main, and this is one thing which came first, right? So what will happen is main would be added on the stack. Okay, like this. So main is added. Okay, it's a method. Again, method got added here. Now inside this we have a local variable which is with the name args, right, which is of type string, right? But we are concerned with this variable name as of now. So where this variable would be installed, this would be staying in under the stack. Again, it's a local variable. That's why. Moving ahead, you created a reference variable of a class which is app, but it's a local variable, right? It's a local variable. So it would again stay here, right? In the next line, what you did was p equals to new app. As soon as you did new app, right, a new object will be formed. A new object will be formed, right? When you form a new object, right? So where does the object resides? Under heap. So here an object will be formed. Okay, and this is of type app. Okay, it's an object here. But what inside app this object will be holding? This object will be holding the instance variables of for this object. What are those instance variables? S and name. These, see, for which class you're creating an object? You're creating an object of which class? App here, right? Right? What are the instance variables involved here? S and name. So what will happen is this object, right? See again, you have to you have to remember and understand, whenever you're creating an object of a class, it's like you're creating a copy of it. Okay, and every copy of that template which is a class, right? What is the meaning? If you create two objects and another object will be get creating, right, and it will have its own set of instance variables inside it. So in our case, we are just creating one object as of now, new app. So an object got created, and what will it will have? It will have its own copy of these variables. What are those variables? S and what? Name. Okay, S and name. Okay, fine. So this part also got covered here, right? Now moving ahead. But okay, next thing, right? We created an object, right? But this object has been given to be referred by this reference variable, which is p, which is this. So p, which is sitting inside stack, would be mapped to a object which is sitting inside heap. Okay, remember this. This is how it works. Now moving ahead, if you go to the next line, again a new method starts work. Where does a method sit? It sits on a stack. So you wrote here work. Okay, now this work method also has a local variable, right, which is of which is with the name app, right, which is of type app class, but it's a local variable. Where does the local variable sits? Inside stack. So you will create app here, right, which is a local variable. Now moving ahead, what you did s equals to new student. This new student, right, new keyword, right, as soon as the new keyword was seen, it means that a new object would be created. See, right, it's an object. So where is that student thing? Right here, it's an empty class, but no worries, it's an object. You will create an object for it. So an object got created here, and it is for the student, right? It's an object for student. So an object got created. Now this object which was created is being referred by whom? By this s variable. Okay, where is this s sitting? This is sitting in as an instance variable. Okay, where is this s here? I don't see an s here. S is here, right? So this s is pointing to this object of student. Okay, moving ahead. Now we have app.setName. Okay, app.setName, it is making an invocation to this method, which is fine, right? We'll talk about it. But I can see a string value being provided. What is string in Java? The string is an object in Java. It's a class in Java, right? And whenever you create a string variable like this, you are creating an object of it. So what will happen is a string object would be created. Okay, a string object would be creating where the value is what? A kill. Okay, right? And if you would see, this is being passed to set name. So let's go to the next line. So set name method again. We'll create that method on the stack. Great. Okay, within the set name, we have another variable, string student name, right? Which is a local variable. So let's add that local variable in the stack again, student name, right? And now this student name, right? By this part, right? So when we invoked set name, right? By doing this student name started referring to this akil object, right? Which is a string object. So what it is referring to? It is referring to this thing over here, right? And inside this, right? And inside this, what is happening is inside this method name, which is an instance variable, right? It is pointing, it is also pointing to the same part, which is this, right? You can see here name equals to student name. What is student name referring to? This part only, right? So this is how it gets moved here. Okay. One thing which I missed is this part, right? When you ran this part, right? Work here. Okay. V s equals to new student. Okay, I think we are good, right? So now try to understand the execution of the flow, right? So this is how things would be placed inside stack and heap, and this is how they would be referring to each other. Okay, so this is very vital information. If you understand this, you are understanding a lot about Java. Okay, now let's move ahead and try to understand the how the execution works, right? Now for JVM, right? We once you start your program, right? JVM looks for this method, main method, right? So JVM will go here, right? JVM will go here and run this main method. Inside the main method, it will see whether someone has passed those arguments or not. Let's say I did not pass, right? So arguments did not receive the value and it is also not used. So it is of no purpose, right? It stays there, right? It is staying there as of now. After this, what happened was it created a reference variable for P, which was there, right? Which is here, right? Which is here. And now after this, it created an instance of the class app, right? Which we saw here, right? It created an instance of the class and it referred with the P part, right? Which is this. Now, inside this, right? What I should have done is I should have also done P dot work, okay, and passed on this P thing, right? Inside this, okay. Now, what is happening here? Once I did the invocation P dot work, it would invoke this method, and here this app. So work again was a method sitting on the stack here, right? So it got added to the stack, and as part of it, it also added app, which was a local variable, which was pointing to what? It was pointing, this app is pointing to what? This object here, right? New app. So this app here is pointing to this object here, right? It is pointing to this object here. Now, and after this, what happened? After this, it ran what? It did this, and then it created a new instance of new student. It created this new student. It referred it by s, so it got assigned here, and then it ran app.setName, which is the next method. So a set name was added to the stack, right? And there it also added student name to it, and this is how the reference went, right? Now at this line, right? At this line, once this piece of code executed, right? Once this piece, I mean this code executed, right? What happened? This was called from where? This was called from here, right? It invoked this method, right? As soon as the scope of this set method completed, this this is this went away from stack. It was popped from there, and also the student name, right? This student name also went away, right? So now we are losing this thing here, so it is not anymore applicable, right? But the things in this heap are still there, right? This string object still exists. These all these things are still existing. So this set name completed. Now, so this line already executed and this line got completed once this completed, right? So as soon as this got completed, so what is happening here? the work method should get terminated from the stack. So, and as part of that, there's a local variable which should also get removed. So app will get removed. Okay. So app will get removed and then work will get removed. So this reference also goes away, right? Now moving ahead, who made the invocation for work? The work was made, the invocation of work was made from here, right? From this part. As soon as this thing completed, right? So this method also got completed here, right? Right? So as this line returned from this part, right, as this line got completed, so this part also got completed. Now as part of that, right, p was a local variable, p was a local variable, so p also moved away from the stack. It was pushed, it was popped from there, right? And once this thing completed, right, it means you ran everything which was inside this main method. So the scope of main methods also goes away. So when it goes away, the local variable args goes away, right? And then the main method goes away from this time. So now your stack is empty. But what about these objects which are staying in the heap? Right? What about them? So you can see, right, everything got removed from here. But what about the object which you created, right? See what happens with Java, right? This object removal and everything, right? This is a responsibility of garbage collector in Java. Okay, this is the responsibility of what? Garbage collector. So you don't have to worry about it, right? So once these are not accessible anymore, right, from anywhere, you can see these are not accessible from anywhere else, right? So garbage collector will run automatically and it will make sure that whatever is not accessible anymore, so it will make sure that those are not kept in heap, and it will keep doing this exercises as per the schedule in which it is designed for doing it. Okay, and in the end everything else will be moved away, right? Everything else will be moved away by garbage collector once it gets executed, and your stack and heap would be empty again. And this is how the memory management works in Java, right? And if you understand this well, right, this will really help you to understand a program which you would have written, right, and compare this to this understanding which I showed you here. Okay, and this is what I wanted to share today. Okay, I hope you like this and you would make some value out of this. Okay, and I mean, this is what I had to share. There is nothing more which I wanted to share. Okay, I hope you liked today's session and it made some value. Okay, thank you so much. Looking forward to the next meeting, and we'll connect there. Thank you so much. Thank you. Bye bye.